I want to talk about the low Tinder hypothesis. This is the opposite of the so-called dry Tinder hypothesis. Okay, for those of you who don't know what the dry Tinder hypothesis is, the idea is that in Sweden, the number of all-causes deaths in the 2018-2019 period were unusually low. This presumably meant that you had this large population of people who would ordinarily have succumbed to infectious diseases suddenly did not. And this means that because you had this large population of otherwise susceptible people, when coronavirus came along, they succumbed. Now, a few online people have taken this idea and run with it a little bit, drawing some interesting conclusions. This one in particular, I'm not going to pay too much attention to the claim that the excess deaths aren't as high as they glaringly look like they are, but I'm going to concentrate instead on this low death rate preceding the COVID and the implications of it. The argument goes something like this. A high mortality rate is caused by a large susceptible population. This seems like a reasonable sort of statement to make until you ask the question, what do you mean by a susceptible population? And if you define it as a population that is actually killed by an infection, then all you're saying is that a high mortality rate is caused by a high mortality rate. Or a large susceptible population means you have a large susceptible population. You're not actually saying anything. So let's try an alternative and more charitable version. A susceptible population is one that is more vulnerable to an infectious disease, so that they're more likely to have a high mortality rate should a disease come along. That's something similar to the definition used by the authors of one paper on the subject, so I'm going to use that one, although even the authors admit that a lot of this is somewhat implausible. However, let that go for now. The basic conclusion then is that Sweden had a much larger inventory of highly vulnerable people. The reason why they had such a high hit rate in COVID-19 was because they simply had a larger number of people, estimated around 4,000 by one paper, they were more likely to succumb to the disease. And the argument for this is largely resting on the idea that the year or so before the COVID-19 outbreak had an unusually low mortality rate in Sweden. And one author goes further than this and says the same is true right the way across Europe, pointing to the fact that even in the relatively unharmed age group, you can see that this death rate is unusually low compared to this period of time earlier. So we have to add the assumption that a large susceptible population is caused by a low mortality rate. So looking at this data, this low mortality rate in this time period presumably caused a large susceptible population, and that large susceptible population resulted in the high mortality rate here. That's the thinking. So just to clarify, a large susceptible population is caused by a low mortality rate, a high mortality rate is caused by a large susceptible population. But there's one other step here, and that is that a small susceptible population must presumably be caused by a high mortality rate. So let's be clear on what we're saying here. A large population of susceptible people exists here. This causes this to have a high mortality rate, which afterwards presumably causes a low population of susceptible individuals. So here's the question. This was a high season as far as mortality is concerned, unusually high. It follows then that this part of the season must have had a low susceptible population. So what we have left is the same argument that says there's a lot of extra people here who are susceptible can also be used to say there's a lot fewer people here that are susceptible because of the impacts of the unusually high previous 2 years. In fact, that would then explain why the mortality rate here was so low, because there were fewer susceptible people. This had basically removed them from the population. And if there are fewer susceptible people here, what caused that? So here's the low Tinder hypothesis in a nutshell. In the European data anyway, we had 2 winters that had unusually high mortality rates. By definition, this resulted in a smaller population of vulnerable people. And that in itself, which would be expected, resulted in a lower mortality rate in the 1819 winter. I submit this hypothesis is simpler because it doesn't require an explanation of why we got this build-up of vulnerable populations. What was the mechanism by which a vulnerable population was not affected by the previous seasonal infections? This is unexplained, and this hypothesis doesn't require an explanation. In particular, if there was such a large population of vulnerable people, why didn't it show up here? the mechanism whereby they were somehow protected from the usual seasonal influenza, but they were very vulnerable to COVID-19, doesn't need to be explained in this situation. It also avoids a possibly circular definition. To describe someone as being susceptible or vulnerable is sort of an after-the-event label. We know they were susceptible to COVID-19 because they died of it, but we didn't know in advance that that was the case. We can't say that they were vulnerable to seasonal influenza because they didn't die of seasonal influenza. So when you have a case where you're labeling someone after the event, this is possibly a circular definition. The low Tinder hypothesis doesn't suffer from that. Of course, this is speculation. It's a hypothesis. But I looked for myself. I encourage you to do the same.